fructose, which I just want to say, again, this may be new to some of the participants this afternoon. Fructose is often discussed on the surface, whether that's in an advertisement that one might see or in some type of basic journal, as though it's just another form of carbohydrate. And I want to be really clear that fructose is very unique in how it's metabolized by the human body. Over the course of human history, and I've said this for the last 25 years in various talks I've given, our exposure, our dietary exposure to fructose has been very limited. We have had limited windows of time with which fruit has been available to us, depending on where we live. Even in tropical regions of the world, fruit is not available year round. Certainly, when you get to more northern latitudes, you have even shorter windows of time. And keep in mind, every animal, every insect, you name it, is competing for that fruit in the 2 to 3 week window of which it's available. So our exposure to fructose as a species has been very limited throughout the majority of human history. And it's only in the last 100 years or so that fruit has been available for much of the year and in the types of quantities that it is now. And it's only been in the last 30 years that things like high fructose corn syrup and agave and some of these very fructose rich sweeteners have been available or have been present in our diet. So it goes without saying, human populations around the world, especially in those more industrialized areas, it's at an unprecedented level. We have never before consumed the amount of fructose that we are consuming now. And we're really starting to see the effects, especially in some of our older generations who have had enough exposure to that fructose, as well as in our pediatric population, which has the highest incidence of non-alcoholic fatty liver disease ever seen before. This all comes down to fructose. It isn't just another source of sugar. It isn't just another source of carbohydrate. It's a very different type. And as I mentioned earlier, when fructose is metabolized, it has to be phosphorylated. When that takes place, you can see on this slide on the far left-hand side, you generate uric acid. By the way, uric acid is a clear biomarker, clearly associated with heart disease, diabetes, a variety of metabolic conditions. It is not simply something we have to be concerned about with respect to gout. And uric acid levels in the body are not, by and large, a function of consuming foods like hard cheeses or sardines or meats. Most of the uric acid in the average American's body unequivocally is a byproduct of fructose metabolism. And at the same time, when we phosphorylate this fructose and the aldolase enzyme comes into play, we form methylglyoxal. That's that advanced glycation end product, often referred to as an age molecule, that we know is responsible for the pathology of mitochondria. So fructose is something that may play an equally pivotal role when you look at dietary qualities or nutrients in the average diet. It is right there with the abundance of omega-6 fatty acids. By some estimates, we can consume around 10 grams of fructose per meal safely, 25 grams of fructose per day. Researchers such as Robert Lustig, who's one of the foremost experts on fructose, has pointed us in this direction with his research. But make no mistake about it, the average American is consuming 3 to 4 times that amount of fructose. And some of those sources are often, under the umbrella of good intentions. And we'll look at those in a moment. And methylglyoxal, it should be noted, is being so linked to diabetes that now it is emerging as one of the more effective biomarkers in detecting diabetes or the progression of that disease, because methylglyoxal is, in a way, as an age molecule or an advanced glycosylated end product, it's a lot like hemoglobin A1C. but it may in fact be an even more accurate representation of the ability of a patient to follow a particular way of eating that's more supportive of what's needed during diabetes. So methylglyoxal is something that you will see more and more in the headlines, especially with its relationship to diabetes. And it probably will be a while before we start to see it being more closely tied to mitochondrial diseases. But I am confident that that day will also come. This methylglyoxal, again, it has epigenetic type effects, so it influences gene transcription. Obviously, as we've talked about, it increases the amount of oxidative stress and damage to the mitochondria. And it also causes a loss in very important viable proteins and the degradation of those. So it's affecting other areas of cellular health, not just the mitochondria. And it plays a big role in the aging process. It's been shown, there's empirical evidence that higher levels of methylglyoxal are responsible for accelerated aging across the board. So whether we're looking at the mitochondria, we're looking at the health of our DNA and how many breaks we have in those strands, we're looking at, really just organ health overall, higher levels of methylglyoxal and an inability to metabolize that and detoxify it is a clear factor in the aging process. And this is an excellent paper on the presence of methylglyoxal in healthy and unhealthy aging processes. Methylglyoxal is also known as a dicarbonyl molecule. This 2019 paper is an excellent one, and it really connects its presence in the diet and the body to a variety of different types of pathologies, not just mitochondrial. Fructose is found in so many different sweeteners at varying levels. You can see agave, for instance, is 88% fructose, which is interesting given the fact that sometimes, certain groups look at agave as being a healthier sweetener. Certainly not the case. Fruit juice concentrates typically have higher levels. You can see that apple juice concentrate is around 67% fructose. So those numbers vary depending on the sweetener. But what I want to make really clear is that fructose can be consumed in a variety of foods that really aren't technically sweeteners. They're fruits for the most part. And so if you look at the left-hand side of this chart, you'll see the fructose content of a typical portion. Obviously, dried fruits are going to be very high because of how concentrated they are. But 1/2 mango, just a half of a mango, has over 16 grams of fructose. So keep in mind, 1 cup of mango would have 32 grams of fructose. Now you've already exceeded how much fructose a typical human can metabolize safely over the course of a day. So you go down that list, or I should say you go up that list, and you get to places where there's some really good news. I mean, 1 cup of cranberries has less than 1 gram of fructose and a wealth of polyphenols and a wealth of prebiotic qualities that feed really healthy bacteria populations, such as Akkermansia. So you've got some really good choices on that list of fruits, and you've got some others that you probably want to save for special occasions. It adds up fast.